We are looking at probability. We have a fair coin is tossed 8 times. What is probability of guessing exactly 3 eggs? At least 1 egg, at most 2 eggs. Between 2 and 4 eggs. So when we have something like this, our n is a number. The n, you can't start drawing it. You can HT. You draw it HT. HT. In 8 times, it will save a lot of time. Can you see HT? HT. HT. This is the third one. First, second, third, till you get to the 8th. It is time consuming, so you just apply. This is N8. Then your S is 3. So you use the formula N combination S, or you use R as it applies. P R Q N minus R. You can do this too. You draw it to the 8th and now start counting H. So that means you write H. You get to 8. 1, 2, 3, 4, 5, 6, 7, 8. That's the first possibility. You go for the next possibility. H. It is time consuming. T. Before you list everything out, so you just apply this formula. We have 8 combination 3. P. Your P is, how many H do you have? It's just 1 over 2. 1 and 2. H and T is just 2. So you apply the probability that you have for coin. Coin is HT. So it's just 2. Probability that is edge is 1. Probability that is tail, you can use for Q, is what? Also 1 over 2. So here, we'll just apply 1 over 2 into bracket R. What is our R? 3. 1 over 2 into bracket 8 minus 3. So we have 8 factorial over 3 factorial, 8 minus 3 factorial. Then 1 over 8. 1 over 2 raised to power 5. This is 1 over 2 times 1 over 2 times 1 over 2. So we have 8 factorial over 3 factorial, 5 factorial. We have 1 over 8 and 1 over 32. So you can expand this. This will give us 8 times 7 times 6 times 5 factorial over 6 times 5 factorial. 1 over 8, 1 over 32. So we have 5 factorial cancel 5 factorial. 6 cancel this. 8 cancel this. So your final answer is 7 over 32. 7 over 32. So that's the first one. That's exactly that we have 3 eggs. Exactly 3 eggs. This is exactly 3 eggs. So that's exactly 3 eggs. H. It's telling us that when we have 3 eggs 7 times, then we'll have 32 number. Because as I explained earlier, you continue to write. You write it H. So it's possible that it appear 32 times. And exactly 3. That means you will have the head 3 appearing 7 times. I can continue from here. You can continue from here. You can continue from here. So this will still be head tail, like that. If I continue, like you can see, we have head. I'll get to this point. I'll still have head, sitting. So it will give off 32 occurrences. And by the time you now have the number that will give you exactly 3, exactly 3. That would be like 7 times. So we want to look at least one edge. At least one edge. At least one edge. Take notes. The first one is exactly 3 edges. Meta, edge meta. This one is at least. When you say at least means from one upward. From one upward. At least you will have one from one upward. From one upward. From one upward. So exactly from one upward. So if it is from one upward, I want us to, you know the reason why I subtracted 8 minus 3 here? Because exactly 3. Exactly 3. Exactly 3. That's why I'm using it. If it's not exactly at least one edge, at least one edge. So we'll just apply 1 minus, because it's one edge, at least one edge. 1 minus the number. You see, apply n combination r, p combination r, q n, q n, q n. So why I'm using subtracting is because I want to use my r to be 0. Then my n will be 8. That means when it is no edge at all, no edge at all, no edge, that maybe you just have 1 t. So 1 t, just 1 t. Then you now subtract it from here, from the 1. So we have 1 minus 8 combination 0. P is half, is C half, combination 0, half combination 8. So we have 1 minus 8 factorial over 0 factorial, 8 factorial. We have 1, then 1 over 56. 1 over 56. So you just subtract 1 minus, this will give us 1 over 56. So we end up having 255 over 256. That is at least one edge. At least one edge. At least one edge. Now, at most means greater than, at most means less than or equals to 2. That's at most. At most, láti 2 wá sí kékeré títí dé 0. So less than, so that means you have 2, you have 1 and 0. That is at most 2 eighths. At most 2 eighths. That's at most 2 eighths. So you still apply the formula when it's exactly 0, 1 and 2. If it is 2, we apply the formula 8 combination 2, q p half raised to power what? 2. Then we have 1 over 2. 1 over 2. So 1 over 2. So you apply it 1 over 2. Because we have at most 2 edge. At most 2 edge. 1 over 2, 8 minus 2. Minus 2. Minus 2. Minus 2. So this is plus 8 combination at most 2. At most 2. At most 2. So, or you can start from 0 if you like, depending. I can decide to start from 0. That will be 8 combination 0. 8 combination 0. We have 1 over 2 combination 0. 1 over 2 combination 8. plus 8 combination 1. 1 over 2 raised to power 1. 1 over 2 raised to power 7. Plus 8 combination 2. 1 over 2 raised to power 2. 1 over 2 raised to power 6. Remember, this is 8 minus 2. This is 8 minus 1. Like that. So we continue. We have 8 combination 0. That will give us 8 combination 0. That will be 8 factorial over 0 factorial 8 factorial. Then half. Then 1 over 2 8. This will give us 1. Plus 8 factorial over 1 factorial 8 minus 1 factorial. We have half raised to power 8 plus 8 factorial over 2 factorial 8 minus 2 factorial. Then we have 1 over 2 raised to power 8. So we'll still end up having this one, 1 over 2 raised to power 8 plus 8 minus 1, that is 7. So by the time you subtract and you open the bracket times 7 factorial, you end up having 8 in the bracket 1 over 2 8. Plus this one will give us 8 times 7 times 6. This will give us 3. Remember, we'll stop at 6 factorial because of this minus 2. So this cancel this. We have this here, we have 4. So this will give us 28. 1 over 2 raised to power 8. 1 over 2 raised to power 8. So from here, we have 1 over 2 raised, that's 1 over 256 plus 8 over 256 plus 28 over 256. We'll add up. We have 256. 9 plus 28, that's 37. 37. Now let's check between. We want to have between. So probability of x equals to 2 between. Probability of x equals to 3 plus probability of x equals to 4. X equals to 4. So we'll calculate for this. We'll still use the same formula. You apply the same formula. We have the same formula. That's 8 combination 2 half 2 1 over 2 raised to power 6. That's q minus 2. That's 8 minus 2 plus probability of 8 combination 3 1 over 2 raised to power 1. 1 over 2 raised to power 7 plus 8 combination 4. We have 1 over 2 raised to power 3 power 2. 1 over 2 raised to power 8. So here, remember when we have 3, this is 3, and this is 5. We have here 4 and 4. 4 and 4. So you expand and solve.